Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
So, have you people practiced the questions that we were discussing yesterday?
Ma'am, actually, I had some work. I've just finished the video.
You have just finished the video. So, you were not there in the session
Yes, ma'am.
yesterday.
Yesterday I couldn't attend.
Okay. All right. No problem. So, just a second. Yes. So, I think that most of you people would have covered a few of the problems, right? And the rest, we are going to see some lead code questions today that are based on dynamic size sliding window. So let's begin with that. And before that, I'm going to share my screen as well. And I think that I'm audible on YouTube as well. So yes. All right. So I'm going to open my Visual Studio Code, and here we are going to share the screen as well. So share a screen. All right. And I hope that it is visible as well.
Yes, ma'am.
All right. So good evening, everyone. So we are going to start with our lead code questions for today. So let us see, right? And here are these problems, right? So these two problems we have discussed already in the class, right? And these next four problems that were quite simple, these were the problems that you have to do, like you were asked to do in homework, right? And now we are going to proceed further for our lead code questions, right? So they are also very much similar in the pattern, but now we have to see to them that how to solve them, right? So one by one, we have to read the problem statement and we have to see that what are these problems exactly. So let's just start with this one, which is 209, and we'll try to match it out that how this is quite similar to what we have discussed in yesterday's session, right? So let's just start with this first problem for today, which is lead code problem number 209209. So 209, right? So it is minimum size subarray sum. Right now, you people have to tell me if it is exactly similar in nature or not, right? So it is saying, so let us first of all read the problem statement. So it is saying that you have to find out minimum size subarray sum. So given an array of positive integer nums and a positive integer target. So you are given with the target and an integer array nums which is containing only positive numbers, no negative number. So you have to return the minimal length of the subarray whose sum is greater than or equal to the target. If there is no such subarray, then you have to return 0 instead. So isn't it the same problem that we were discussing yesterday, the first problem? That you are given with a target and you have to find out that what is the minimum size of that window which will give you a target sum greater than or equals to this target. Isn't it, guys? It is
Yes, ma'am.
absolutely similar to that. So this will, like, this we can do, right?
Exactly same नहीं है.
Exactly same.
Hmm.
So you people can do this, right? Now you have to do it because you have to run the test cases and all the things, right? So you have to basically solve it here, right? If you have figured out ON solution, try coding another solution of which the time complexity is n log n, right? So it is saying that if you have figured out some sort of solution in ON time, which we have, right? So it is saying that can you solve it in ON log n time as well? Is there any way to solve it out in n log n time?
मैम n log n ज़्यादा टाइम हो गया ना n से.
Yeah, but it is asking us that is there any kind of solution which can solve this in n log n as well? So even though that it is going to take more time, but still it is asking. So is there any solution that can do this?
um,
Think about it, everybody. A solution which can give us the answer in n log n time. Okay. You people think about it, right? This is your homework
Can we
question.
sort the array here?
You cannot sort the array because we are talking about sub-arrays.
Okay.
Take your time, right? Try to solve it. We'll jump on to the next question. But this is the task that you have to do. First thing, that you have to solve it like within ON time, right? That you can do because we have just discussed about it. And then you have to figure out that is there any kind of solution which can give us n log n time complexity as well, right? And then we will take this question again in the next session, right? So before that, I want you people to like have a good time with this question, right? So let us move to the next question, which is question number 76. Now let us see if this is also similar or not, because it is saying that it is on the same pattern, which is the smallest window is greater than or equals to the condition. So let's see that what is this question. So it is lead code question LC 76, right? So minimum window substring. So it is the question which we were discussing yesterday, the second question, I guess. So let us read it out. So it is saying that you have to find out minimum window substring. So given two strings S and T of lengths M and N. So suppose S is one of the string which is of length M and T is another string of length N, right? Return the minimum window substring of S. So you have to return minimum window substring of S such that every character in T, including the duplicates, is included in the window. If there is no such substring, then you have to return a empty string, right? So there is a substring, there is a string T that you have to find out in substring, in string S, if there is some sort of substring that contains all the elements of T, which is in S, then you have to return that particular substring, or otherwise, do you have to return true, false, or the string itself, right? So you have to return the minimum window substring is B, A, and C, because B, A, and C, three of the letters are present. So that's why this particular substring is the answer. Right now it is saying, I think that it is saying that you have to return the minimum window. So out of all the possible answers, the answer that you have to return is going to be the one which is a minimum in length, right? So maybe there are many possible answers. So for example, this is also one of the answers. This substring is also containing A, B, and C. But length of this substring is 6, whereas this particular substring is also containing A, B, and C, but the length is only 4. So you have to return that substring which is having a smallest length, right? So this is the question. Is it clear?
yes, ma'am.
Again, the very similar question to what we have discussed earlier. Can we do
Yeah.
it using hash map?
हाँ वैसे हैश मैप यूज करना पड़ेगा ना वो ट्रैक करने के लिए.
Absolutely, because here duplicates are also allowed, right? You have to use a hash map which is going to keep the counter of each of the individual letter. So I'm going to give you a slight peek into this, that how we are going to solve it, right? Even though we already know all the things, but still we have to discuss a little bit. So whiteboard, let us open this one first of all. Whiteboard. And now you have to see to it that what we are doing here, right? So we basically want a counter is needed, right? Which can keep count of how many A's are there and how many B's are there. So we want to keep a count of that. So let us see. All right. So let us discuss this one. This is going to follow a slight different, approach. So we are going to take help of hash map and things. So let us see. So it is saying that suppose this is our, this is our first string S and this is our T string. And it was saying that you have to find out this T string inside this S string such that the length of the window should be minimum, right? This was our condition. We have to go for it. So now we're going to start with a window, right? So first of all, ABC we want. So ABC we have kept inside this hash. You can take a hash table as well. So in this hash table, we are keeping this A equals to 1, B equals to 1, and C equals to 1, right? So this is our hash table number 2, right? And you people know that how this hash table works. So 0 represents A, then 1 represents B, and 2 represents C, right? So this is why these three letters are marked as 1. In the similar way for this window also, for the window which we are going to run on this particular string, for that also we are going to keep a hash table. So this is also 26 letters long, and this first hash table is also 26 letters long, right? So the size of this hash table 2 and hash table 1 both is equals to 26. Now we are going to start with the window which is of size 3. So when you will like start with size 3, you can start with size 1 also, but these matches are going to give you answer. That is, there is no such match, right? And then you can simply run this run through run this sliding window approach. So A is marked with 1, then B, then C, they are empty, and then D is marked with 1. And then somewhere here we'll have this O as well. So A, B, C, D, and O, this simply means these indices 0, 1, 2, 3, 4. For simplicity, I'm writing here A, B, C, D, and then O is also marked as 1. And now we will start to check that are these two hash tables same, right? The similar question we have done already, right? So now we are asking that can we when we are matching, we are trying to check that is this particular hash table 1 equals to hash table 2, and the answer is false, that they are not equal. If they're not equal, now we don't have to check exactly for the equality. We have to check that all the elements of hash 2 table are present in hash 1 or not. So we are
Hmm.
basically checking that if this first element is marked as 1, right? So in hash 2 table, we are checking that which all elements are marked with 1, 2, 3, 4, whatever, right? So here it is marked with 1. So we just have to simply go here and we have to check that is this A containing 1 or not. So we just have to check that all the elements of hash 2 are present in hash 1 or not, right? So you have to run a for loop for 26 times and you'll get the answer. Then similarly, now because you have not got the answer yet, so you're going to increase the size of your window. Now you're saying that, okay, let us increase the size of window, and this time B is also included, because obviously you have to increase the size of your window until you are not getting the results, right? So
Yeah.
until the point that your condition is not satisfied, है ना, it is not satisfied, you have to increment the right pointer to
Yes.
increase the length of the window, and when the condition will be satisfied, at that moment you have to increment your left pointer, because left pointer, when it increases, it decrease the size of your window. But right now
Yes.
the condition is not satisfied. If it is not satisfied, because B is marked as 1 but C will not match, right? We want to check that, okay, is 0 and 0 equal? The answer is yes. Is 1 and 1 equal? The answer is yes. But is 2 and 2 equal? So here it is 0 and here it is 1. So the answer is that no. If not, it means that the condition is not satisfying still. So we have to go on increasing the size of the window. So again, this time E is also included, right? So whatever extra is there, that doesn't count. We just have to check that is hash table 2 and 1 should match. So this time E has also come. So E is also marked with 1 because it is coming for the first time. And now again we are checking that, okay, is this condition satisfied? And the answer is no, because C and C will not match. Here it is marked with 1, here it is marked with 0. So we'll again increase because condition is not satisfied. So you know that you have to increase the length of your window this time. So again, we are increasing the length of the window by incrementing the right pointer. Right pointer means the pointer which is at the end of the window, right? Then again, this time C has come. So this we will mark as 1. And this time when we'll check that hash table 2 0, is it equal to hash table 1 0? So the answer is that yes, hash table 1 0 is equals to hash table 2 at 0th position. So answer is true. Then we'll go for the next match, that is for 1. Again, the answer is true, that yes, both of them are equal. Then we are going to match for 2, and then again we are going to get the answer as yes, they are both equal, right? So whenever there is any 0 present in the hash table 2, we don't have to match any kind of thing to it. But whenever some value is there which is greater than 0, at that moment we surely have to check it inside hash table 1, right? This is the complete logic. And then you will find the length of the substring to be 6, right? So this we are going to update over here. Then obviously, whenever the condition matches, you have to move your left pointer. So as soon as you'll move the left pointer, what will happen? A will become 0 again because A is leaving your window. So A will become 0 again. And this time the condition is not satisfying because A and A will not match. So that's why you are going to increase the size of your window. Because whenever the condition doesn't match, you have to increase the size. Right? Again, the condition is not matching because we are not having A, so we will increase the size of window. Again, A is not there, so increase the size of window. Again, A is not there, so increase the size of window. Right. This time, so B is also not going to match, but A is also not there. So again, increase the size of window. At this moment, you will have A equals to 1, but think about B. B is 2 at this moment because there are two B's inside this window. So when you will try to match these two hash tables, so what will happen is that A is equal, that is 0 index is equal in hash table 1 and hash table 2, but B is not equal because here it is 2 and here it is 1. And it was saying that how many B's have appeared in T string, that many characters should appear in the first string substring as well. So that's why this condition is not matching. And you people know that when the condition doesn't match, then what do we do? When the
Left
condition
pointer.
doesn't match, we increment
Left.
the we
Right. Right.
increment the right pointer, right? So we'll keep on incrementing the right pointer only because the condition is not matching still, right? So here as we are thinking about it, so here basically the problem will come. So here there is one more case that we have to on keep track of. That is whenever the count is more, that time you have to decrement the pointer from this side. Right, so this is the catch for this particular problem, right? So let us now decrement the pointer from this side. So D will be excluded, then again O will be excluded, and this time B will also be included. So there are two cases where your left pointer is going to work. So either the condition is satisfying, or other than this, if the condition is not satisfying, but the count is more. So if count is more of any of the variable, then also you have to move your left pointer, right? So this was the catch. And that's why it was the hard problem, right? Because it is not a direct implementation. You have to keep in track this condition as well. Then again, if you'll go ahead this time also, A, B, and C, all three of the alphabets you have got, and one time. So this is also one of the string that can become our substring, but the length of this substring is 7, so we are not going to update this length because we want to find out minimum length. Then whenever the condition satisfies, we move the left pointer, so we'll move the left pointer. Again, A, B, and C, all three letters are present, so this is also a correct string, and the length is 6, which is already updated at this point. So then again, if condition satisfied, we move the left pointer. At this time, the condition is not satisfying, so we have to move our right pointer. So N is included, again not satisfying, so right pointer. This time C is included, so this is also a correct substring, but the length of the substring is 7. So we have to move our left pointer, again left pointer, because at all of these strings, we have satisfaction level is there, right? this time when we are at BA and C again, substring is satisfying the results. So the condition. So this time again, we are going to compute that what is the length. It is 4, which is smaller than 6. So we are going to basically make it to 5 and then 4. And this is how we have got the answer, right? 4 as the final answer. Does it make sense? So there were
Yeah.
two conditions where left was moving, right? So you have to move left here at 2 points. One, when the condition is satisfied. What is the condition? Condition is that you have to get all the elements of T string in the substring that you are searching for. And the other condition in which left pointer has to move is when the number of the count of characters, right? The count of characters of T string that we're searching in hash map 1 is more than what it should be. So, for example, if there are more number of A's or more number of B's or more number of C's, then you have to increment the left pointer instead of right. Right? And when does this right pointer move? So, right pointer moves when the condition is not satisfied. Right? If the condition is not satisfied, so you have to move your right pointer. So these were the two cases of movement. Is it clear?
मैम लेफ्ट पॉइंटर, वो जो दूसरा केस है उसमें वही ना कि हैश वन में कैरेक्टर नॉन जीरो हो और हैश टू से बड़ा हो.
Hash 1 should have, so for example, here B was only 1. That is, that B has occurred only one time in hash 2. It means in T, it is only coming for one time. But in
हाँ.
hash 1, it was there for two times. So we were saying that
हाँ.
if the condition is satisfying, that is A, B, and C all are present, right? But the number of times B has appeared is more, right? Uh, in fact, even if C is also not there, but still if B is coming for more than more than one time, it simply means that this is not a correct string. And whenever correct string is not there, so usually we move the right pointer. But here, because the count is more, so that's why we have to move the left pointer for this particular case. When number of
तो वही
characters are more, right? Is it clear, guys?
मैम वो वही नॉन जीरो वाला कंडीशन लगाना पड़ेगा ना, क्योंकि वन इधर वन है और उधर जीरो है, फिर भी वन बड़ा है ना.
Here we have 2 and here we have 1. Here we have 2 and here we have 1. So at this point, even though the case is not satisfying, you have to move the left point. Can you draw this in your notebooks first of all? Draw it in your notebooks, you'll get the point. Try to dry run your code first of all. This is your question number. So it is little bit different than what we have discussed yesterday. It is question number 76. Try to dry run this code first of all. Dry running simply means that you have to run it simply like how we were doing it on a screen. Right? Try this out first of all. Is it clear, everyone? Would you be able to do it, guys?
ट्राई कर रहा हूँ।
Yes, in hash table 2, you are going to have in ABC, you are going to pre-fill that table, है ना? So yes,
हम्म
ABC will already be containing your 111. You have to just work on your hash table 1. Hash table 2 is already pre-filled. Like you have to do pre-filling of T string beforehand, before starting with your tables, before starting with your window. Definitely. At the time of comparison, you can simply do what is that if you people want, then I can help you with the algorithm as well. But first of all, you people try to get some sort of like idea that how to go for the algorithm as well.
हम्म
That's really good. So one of our student has already solved it. So have you used hash map or hash table concept only? Hash map is also a kind of hash table. If you people can dry run it, then you will be able to code it as well. So, by the way, what are the constants? Are we having capital A, B, C, D only? Or are we going to have a small a, B, C as well? Acha, uppercase and lowercase. So, if so is the case, then
डॉट लोअर
yes, no, don't do that because uppercase and lowercase both will be treated differently. So, you can have an array instead of having it of size 26, what you people can do is that if small and capital both letters are involved, then you can like keep your zeroth index fixed at capital A, right? And you will create an array which will go up till this is small z. So zeroth index is for capital A, and you have to do the subtraction of every time with capital A. And I think it is starting from 97, add 26 to it. There is 13, 9, 10, 12. So I think 123 is the last one, last ASCII value, and 65 is the first ASCII value. So you can simply subtract the values and you have to, like, you will get some value out here. That is 11, so 4, 5, some 50. Because in between there are some characters which are not alphabet. So that's why I'm counting here. So 58 is coming out, 6. So you can do something of this sort also. Otherwise, if you don't want to do this also, then you can start from zeroth ASCII value itself, and you can keep your last index to be 123. So that will also work because this is not a very big hash table. So now 65 will only be considered as A. So any kind of mapping can be done, right? If you want to use zeroth index as capital A, then you have to subtract every time A from all the characters that are coming out, right? Because A will become our base. And if you want to use 65 only as A and 66 as B and 67, like the actual ASCII code as their hash, as their mapping value, then you can create an array of size 124 or 123. So that is also one of the ways to, develop that hash table for this question. If a small letter and capital letter both are allowed. So that is the only change that you have to keep here, that you have to keep in mind, that you have to apply over here. Is it clear, everyone?
हम वो स्मॉल वाले को कैसे इनकॉर्पोरेट करेंगे एक बार फिर से?
So suppose a small a is, now we have taken, suppose let's say we have taken an array of size 123, 124, right? So if suppose we are taking direct values, so a will be at index number 65 and a
हम्म
small a will start from index number 97. And if
हम्म
we are like taking an array of 56 size, because we just want to have a small a and capital A's only, right? 56 or 58, whatever the difference was.
हम्म
Difference of capital A minus a small z. So this will give us that how many values are there in between, right? Capital A and a small z. So now we want to know that what is the index of a small a here. So you can simply say you have to subtract every time capital A from all the letters, upcoming letter, because you have made your base at capital A, right? Zero is now known as capital A. So if you want to find out the index of capital C, so you're going to subtract A
वेट,
from C.
कैपिटल ए और स्मॉल ए डिफरेंट ट्रीट हो रहा है?
Yes, in this question, they're treated differently, right? So A
यस.
minus C will give you index number 2. So 0, 1, 2. 2 basically saying capital C. And if you want to find out that what is index for small a, then A minus A will give you 65 minus 97. So whatever this index will come, that will be treated as a small a, right? Our base value from which we are subtracting all the values is 65 in this case, right? So it will be A minus capital E. So that is the only thing that you have to keep in mind, that you have to subtract capital A from all the upcoming values, right? Baki, the rule is going to be same. That is, you're going to have an array and there is going to be a base array hash2 table in which you're going to keep all the values of a string T, that how many times which letter has appeared. And then you have to have a sliding window in which you're going to see that how many times the alphabets have appeared. And we have to check only for those letters which are present over here, right? You have to keep this in mind, that you have to check only for those letters which are present in hash table 2, right? You don't have to go for any other checking. So that means that you don't have to go for checking 3, because 3 is already not present in hash table 2, right? So that was the only condition that you have to keep in mind. So would you be able to try this, guys? Question number 76,
यस मैम.
right?
मैम
You
अगर
have, uh,
अगर फर्स्ट वाला, जैसे मैं ए पे आया, चेक किया ए है, उसमें भी है, फिर मैं क्या करूंगा? राइट राइट को मूव करूंगा?
yes. So you are starting checking from index number 0. If 0
हम्म
is there, that is hash 2 0 is there, and it is 1, right? Then we have to check it, that is it equals to the value that is inside this hash 1a,
हम्म
right? If the answer is that yes, it is there, uh, and the values are equal, then we can go for index number 1. So we have to check all the possible values, right? If the size of this particular array is 26, then we have to check for 26 values. Otherwise, you can keep one more flag in which we are like one more flag you can keep, which is going to uh, have all the character count, right? It will tell us that how many characters are needed. So something like that also you can keep, right? Like how many have been matched and how much we want to match. So how many letters we have to match, that you're going to find out using the length of t, and then character counts will tell you that how many you have already matched. So as soon as these two counts will become equal, then you don't have to go for further matching. Right. So just try this out first. If you won't be able to solve it, then tomorrow, in tomorrow's session, you can remind me and I'll solve it. Like we'll solve it here together. Right? But before that, you people can also try this, right?
Yes.
Guys,
Okay, ma'am.
okay?
Yeah.
And then one more thing that we have to check here is, all right, that we have already done. This is the next question that we have to try now. So this is 643. Let us see this one as well. Just remind me if you people are not being able to solve it, then I'll help you, right? But I think that you will be able to solve it. So this is maximum average subarray 1. So you have to, so it is an easy problem. So I don't think that there is much to solve it. I think we have solved it already. This is
Yes, ma'am.
static sliding window question. So this you don't have to solve.
Already solved आ रहा है.
Already solved. Then 1100 also.
दिखाना एक बार. एक मिनट.
LC 1100 elite code. This is also
ये
done, right? This is
लॉन्ग है,
also
लॉन्ग.
done. Yeah, we have solved it on Algo Monster, right? Remember?
या नीट कोड आया पे. हाँ.
Yes. So this also we have solved. Now let us move to the next question. All right. Now they have changed the criteria. Now they're saying that there is largest window question. So just the opposite of it, right? It is also not a very big deal for us. Let us see this question. It is question number 3. Let us go for it. And I'm closing these questions right now. I'm expecting that you people are going to solve these two questions because these two are not required because these we have solved in a static part. These two questions we want them to be solved, right? And now we are going for the next question, which is question number 3. Let us see this as well.
और
All right. So it is saying that longest substring without repeating characters, right? So it is saying that you are given with a string S and you have to find length of the longest substring. So in other questions, it was saying that you have to find out the length of the smallest substring that is possible. Now it is saying that you have to find out largest substring with without duplicate characters, right? So it should have all characters non-duplicate, right? So this also you can do. Like if we will simply discuss this question, then this is just the opposite of what we are doing till this point. Let us see. So this is our string in which we have to find out that particular substring, right? And that substring should be maximum, right? So we'll start from this place, right? Right now our left is also pointing to A and right is also pointing to A. And we can keep a hash map to keep track of that how many letters are there. You can keep track in a hash map also, in hash table also. For this question, we're going to take hash map instead, right? And we are saying that, okay, A has come for one time, suppose, right? Because we want to try all the things, so that's why. So this time A, because we are traversing the window, this time A is there and we have kept the count of A in this particular hash map, right? And hash map is saying that, okay, A has come for one time. So this is a substring with a unique character. So that is what we are going to update in the length as well. And we have to find out the length of maximum such substring possible. Then we will increment our window, right, when the condition satisfies. So we are this time saying that because this is just the opposite question. So this time we are going to say that if the condition is satisfying, then we have to increment the right pointer. That is, we have to increment the size of our window. So let us increment the size of window. So as soon as you will increment the size of your window, B will also be included in the window. And you will say that because this particular B string is not present, So B is also a part of my hash map, right? Because this is also a unique character. So we are including B also in the hash map. All right. Now, can we update the maximum length of the substring? Obviously, because 2 is greater than 1 and we have to find out the greatest one possible. So this is also included. Then again, we are going to include increase the size of our window, and C will also be included. Now we are trying to find out that is this C already present in the hash map, and the answer is that no. If no, then we can include C also in the hash map, and now the maximum length is equals to 3. Then again we are going to increment this size of window because this condition is satisfied. So this time the only condition that has changed is that if condition satisfied, then you have to increment the right pointer. And if it is not satisfying, then you have to move your left pointer. This is the only change that is happening. Now we are saying that okay, A is also included, but this time A is already present in the hash table. So we are going to mark it as 2, and then we are going to say that now it is time to increment your left pointer. And as soon as you will increment the left pointer, A will be excluded from the window. And because A is excluded from the window, so this count will become 1. Right? Again, the maximum length is still 3 because all the unique characters are there. Then again, we're going to increment the window size because the condition was satisfying. But again, B has come. B has come means the count has increased. And we know that whenever the count increase from 1 to 2, that time we simply know that this is not a condition being satisfied. So at this moment, we have to decrease the size of our window. So we are saying that, okay, let's decrease the size. And once again, we have all the unique characters, right? 111. And at this moment, we are going to check that, okay, these all are unique, but what is the size of this substring? So size is basically the size of hash map itself, which is 3. So that is already updated. And this is how, because now it is satisfying the case. So you have to increment your right pointer. So again, C will become 2. And whenever the key is already present, at that moment, we don't take the size of our substring because we know that there's some duplicate. Right, so we have to decrease the window size, that is by incrementing the left pointer. And again, we have all the unique characters, but the problem is that in these unique characters, the length is still 3. So all right, let's move on and let's include the next element inside. So we have come with this B. So here it is 2, right? Then if it is 2, then you have to decrement your window size, which you can do by incrementing the left pointer. And this time this A has gone out, right? A has gone out, right? So now we can see that B is still with two values. So if the value of B is still 2, then we are going to say that you can simply check it how you can check that there is a duplicate. You can check the size of your substring. Your size of substring is left minus right minus left plus 1, which is equals to 3. And what is the size of your hash map? So you're going to check the size and it will come out to be 2. It simply means that there is some sort of duplicate, right? So it is very easy to check that is there any duplicate or not. So obviously some duplicate is there. Duplicate is there. It means that you have to increment your left pointer, right? So again, we are going to increment the left pointer. So incrementing this time B has gone out. So the value of B is now 1, right? Now we are checking that what is the current length. So it is 2, and what is the length of this hash map? It is 2, but still we are having some bigger value in the length. So we are not going to update that. And then again at the end, you're going to increment this right pointer and B will have its value as 2. And again, this is a duplicate, so you have to decrement the value of your uh, window. So window size will be decreased. Again, duplicates are there. Window size has to be decreased. Again, this time only B is there. And this is the place where you can stop your computation. Is it clear?
Yes, ma'am.
So will you be able to do this, guys?
Yeah,
Online, everyone?
yeah,
On YouTube, everyone? Is it simple, guys? Would you be able to do it? This is exactly similar to what we have tried yesterday, right? We've done coding for this one. Ketan, हो जाएगा. All right. So let's move to the next question. So it was pretty simple, right? So real cookie, I don't know your name. You can come with your real name, then it'll be easier for us, right? So now let's move to the next question, and it is 340. Let us see this one as well. So this is a question on lead code 340, right? And if you will do the question with the same pace, you will see changes in your coding style very soon. Like you will be able to like code very fastly in a little to no time, right? So you just have to keep on doing this small coding things that we're doing, these some of the questions that we are solving, because they are very much relevant to a particular topic. So it becomes very simple to understand that particular topic also, and it becomes very easier for us to follow on with the next questions as well. So that's why it is going to help you guys if you can stick to this regime, right? So I just want that you people, whoever is attending the session, I want you people to be regular. Like, don't miss your classes, right? This is how we're going to build a very good coding background for ourselves. Right? Later on, we'll have some very difficult problems as well. But any which ways, we're going to do with them now as well. It's just that you have to ask me a lot of questions whenever you feel uncomfortable for any part of a problem. You can ask me, and you have to solve these questions. If you do that, then you will be able to uh, will be able to go through any kind of technical interviews as well. Right, let's move to the next question now. So it is question number 340, and it is longest substring with at most k distinct. All right, now this question has changed and it has come for at most. So you'll be able to do this as well. Let us see this question on Algo Monster, right? Because we want to know that what is this question. So you are given with a string s and an integer k, right? So one string is given and one integer k is given, and your task is to find the length of the longest substring within S that contain at most k distinct characters. So previously it was saying that you can have as many distinct characters as you want. This time there is one condition, that is it will give you the value of k, right? And you cannot have more than k distinct characters. So this is what has changed. For example, it is saying that if suppose is equals to ECEBA and k is equals to 2, then you have to find out the longest substring that we can make from which will contain only two distinct characters. So this is the question, right? The question is that suppose this is your example, right? This is your example. So in this example, it is saying that you can have at most two two distinct letter to make your string uh, correct, right? So you are starting from this place. Now what happens is you are asking that, okay, how many unique characters are there? So the answer is that there is only one unique character. So now the question is that, is this a valid substring? And the answer is that yes, it is a valid substring because the number of unique characters that are required at most are 2. And if the value is less than or equals to k, then definitely that is a valid substring. So right now this substring is valid. So if it is a valid substring, then obviously we can increase the size of our window, and to increase the size of our window, we always go for right plus plus. So, all right, let us increment the size of our window, right? And C will be included in the window again. Right, now we are asking, okay, how many distinct letters are there? And your answer is two distinct unique characters are there. So is this a valid string? Definitely a valid string. And what is the length? So length is 2. So we have updated that as well. And because it is valid, so that's why we can go for right plus plus. right? Because whenever the string is valid, we always have to go for right plus plus in this question. Then again, we are checking that, okay, how many distinct, unique characters are there? So there are only two distinct characters, and K is allowing us to have two distinct characters. So again, what is the size of this substring? This is a valid substring. So what is the size? Size is basically 3. So it is bigger than the previous value. So that's why we can update it over here. So you have to get the largest possible length of any substring. So that's why we are updating it here. So largest one is 3 for now. Now we are going to again increase the size, and this time B has come. So because of this B, the number of unique character value has changed to 3. But this is not allowed because it was saying that you can have only two distinct letters, and now you're having 3. So this is the place when your string is not valid, right? This is a case of not valid string. At this particular case, what you have to do is you have to do left plus plus. You have to decrease the size of your window, because whenever you do a left plus plus, your window size decreases. And this time we are checking that, okay, how many unique characters are there? So still there are 3 unique characters. So this is also not a correct string. So again, we have to go for left plus plus. Now we are checking that, okay, how many unique characters are there? So obviously there are 2 unique characters. So this is a valid substring, but this valid substring is having length 2, and a substring which is bigger than this one is already there. So we don't update this length right now. Right, and then again you have to, because this is a valid string, so you have to go for right plus plus. So EBA, and you people know that EBA is containing 3 unique characters, so this is also not a correct string. So left plus plus has to happen, and this time it is BA. BA means 2 unique characters, but bigger than that. 3 is already there. Then again, A is there, which is a single character window, and this is the end of it, right? Here you can stop. So this is how you're going to move your window in this question. So can we do this question?
Yes, yes, ma'am.
Yes? Can you, okay, do one exercise, guys, because this is also again a very similar kind of question. So now there is one simple exercise that you people can do in English, right? In English, not in the coding language. In English, just write down this algorithm very quickly, that how you're going to store these characters, how you're going to maintain this unique key, how you're going to maintain this length, right? Because this is also very much similar to the previous questions that we have done, right? So I just want you people to write in English that how you're going to run this algorithm. How what are the steps of this algorithm? Write it down in English. The steps of this algorithm. I'm giving you 2-3 minutes. Just try to write it down.
हो गया मैम।
Done?
Yeah.
All right. So other questions are very much same, right? So
इसका
now you
आंसर
people
आंसर 3 आएगा ना?
answer will be 3, right? Because ECE, this particular substring, is
हम्म,
the longest one with two distinct character because the value of k was 2, right? So answer will be 3, and you can check it over here as well. Your final answer is ECE,
इसी
right?
yeah.
All right. So, in the similar way, right now, these questions are enough, right? So you can try these 4 questions, and at most K question also you have done. So just try these 3 set of questions, right? Other questions also you people can do very easily. And if you people will have any doubt in dynamic sliding window, this core concept, then we'll carry on this part also. But otherwise, we'll move to some difficult level questions from either sliding window, that is mix of a static and dynamic sliding window, or otherwise we'll move to prefix sum. Right? We'll see to it tomorrow itself. But before that, you people, this one highlighted portion, this much you have to cover. Right? You people have understood the algorithms very well, right? Isn't it,
हम्म,
guys? Right.
yes ma'am.
So you
Approaches.
have approaches you have understood, right? You have seen the implementation also in yesterday's session, right? So it was
Yeah.
very much same, so that's why I was not implementing them today. Right. So you have understood the implementation also, you have seen these problem statements as well. So these many I think that you'll be able to do by tomorrow, and then we'll discuss further whatever different types of questions come, right? If some concept is needed, so that also I'm going to teach. And yeah, so this is how we have to proceed further. So right now, I just want you people to try these questions, right? Everyone,
Okay. Okay.
okay? All right. So for today, we are going to have our session up until this point, but tomorrow it is going to be very interesting. So just prepare a little bit, right?
Ma'am, tomorrow new topic or discussion of these questions.
Complete. I will try to have a new topic, right? But I want you people to try it first. If you people will have some problem, then we'll have discussion over that question as well.
Okay.
Okay?
Okay.
So it is going to be either the hard part of the sliding window, or if you people will not be comfortable, then we'll go for some another topic which will be helping us in solving the hard questions. Right?
Okay.
All right. Okay, guys, good night. And everybody has to try these questions. If you people have any doubt, you can ask me right now. Otherwise, I'll wind up the session for today.
हाँ,
No?
ट्राई करके बता।
All right, guys. Chalo. Bye bye, guys. Good night, everyone. Take care.
गुड नाइट।